So today we'll be learning about anti-nutritional factors. So here we'll be talking of trypsin inhibitors, phytates, oxalates and pressure amines. Okay. So we'll understand first what does anti-nutritional factor mean and how is it impacting on animals, plants in both the aspects, negative, positive. Right. So if we talk of what are ANFs basically, these are the compounds which are naturally present in some biological sources and which will interfere with the absorption of nutrients, and as a result of which this nutrient bioavailability to the body will not be there, right? So it will obviously hinder the metabolism which is there, physiological processes which are there, and as a result of which it is termed as anti-nutritional factors. Anti meaning reduction of the nutrient uptake to the body, right? So if we talk of the negative aspects which are there, obviously one is impaired nutrient bioavailability to the body, which will result in certain health issues, right? And if we talk of the positive aspects, now we do know for a fact that plants require defense mechanisms to survive abiotic, different kinds of stress, right? So here plants will generate these anti-nutritional factors so that it will be surviving from birds, insects which would eat these plants. And second would be nutrient absorption. Now nutrient absorption, we know it's impaired, but it is needed. This impairment is necessary in some cases, right? So some ANFs are phytates, tannins, oxalates, lectins, saponins, right? And there are different foods like grains, legumes, and certain vegetables. So let's start with trypsin inhibitors. Trypsin inhibitors, as the name suggests, it will inhibit trypsin enzyme, right? So they are also known as serine protease inhibitors because the trypsin has serine in its active enzyme, right? So the sources of trypsin are soybeans, grains, cereals, and various additional legumes. So it will basically reduce the biological activity of trypsin. Now trypsin, we know that it is basically a master activator, right? Because of this enzyme, many other enzymes are getting activated, like chymotrypsinogen to active chymotrypsin, or proelastase to elastase, or prolipase to lipase, right? So this is like a master activator, and this trypsin inhibitor will basically inhibit the activity of trypsin. So we'll understand the mechanism, how is it acting exactly. So here is the structure of trypsin inhibitor, wherein somewhere here it will have a lysine residue. Lysine, as we know, is a positively charged amino acid, and here is the active site of trypsin. Trypsin has histidine, serine, and aspartate at its active site. So this lysine will bind to this active site of trypsin, as a result of which this whole enzyme will be denatured, right? So this trypsin inhibitor, we can say that it will act as a substrate analog, and it will go and bind to the active site, as a result of which this interference will cause a disruption in the orientation of the enzyme, right? So as a result, this serine residue will not be able to produce a nucleophilic attack, generate a nucleophilic attack, right? And these proteins will not be cleaved, and as a result of which this protein digestion would be prevented. So if we talk of the benefits versus hazards, benefits is obviously this trypsin enzyme is regulated by inhibitors, right? Second thing would be it reduces fasting glucose, it reduces the release of inflammation factors, then antimicrobial activity is good in ANFs, trypsin inhibitor basically, and then it is one of the supplementary treatments for obesity or overweight or obesity. And if hazards we talk of, if this inhibitor is inadequate or somewhere mutated, then what will happen? The trypsin concentration will not be regulated, right? And as a result, what will happen? The trypsin will be in activated form. It will start digesting even its own cellular proteins and will cause inflammation to the pancreas, which we in medical terminology call as acute pancreatitis. Okay. So now let's talk of phytates. Phytates, here we can see there is an inositol and there are these different phosphates. So we can say it's also known as inositol hexaphosphate. So basically it's a primary storage form of phosphates and inositol. Sources would be whole grains, legumes, prominently nuts and seeds. Like trypsin had a protein effect, right? This phytates have mineral. So basically it will lower the bioavailability of minerals like zinc, ferrous, magnesium, calcium, manganese, copper, and nickel, right? So it will, and second thing would be it interacts with proteins, resulting in reduced protein solubility. So phytates are strong chelators which will form a mineral phytic acid complex, which would be basically hindering the mineral absorption which is there, right? So if we talk of the mechanism of action, again here we can see these different phosphate groups attached to the mineral ion, correct? So what would happen, these phosphate groups will attract these positively charged mineral ions, and this is the way they'll form mineral phytic acid complex, and this complex will lead to formation of these salts, and as a result of which there would be reduced bioavailability of these certain minerals which are there in the complex, right? So this is how it works. And again, if we talk of benefits versus hazards, then benefits for phytates would be it has great antioxidant properties. Chelation, as we saw, is good. Anti-cancer properties, then cardiometabolic health, then blood sugar regulation, and gut health. And if we talk of hazards, obviously the mineral absorption is inhibited here, as a result of which this mineral or micronutrient deficiencies would be created. Then it will have an impact on bone health because calcium ions which we saw, then gastrointestinal discomfort, and obviously it will have some hindrance in the medication bioavailability as well. Now let's talk of oxalates. Oxalates very similar to phytates, but the only difference is it will form insoluble salts of calcium oxalates, which are very prominent because they have a high risk of generating or producing kidney stones. Sources, if we talk of, are spinach, rhubarb, then beets, nuts, chocolates, etc. So effect, the prominent would be it will interfere with the calcium absorption by forming insoluble salts, and this calcium oxalate crystals, if they are formed in large quantities, it will increase the risk of kidney stones. Now if we talk of the mechanism, it will be very similar to the one which had phytates, right? Here is the oxalic acid binding to calcium ions, which will result in this insoluble calcium oxalate crystals, which will impair the bioavailability of calcium, and as a result of which this calcium insoluble salts, calcium oxalate insoluble salts, will form kidney stones. So again, benefits versus hazards. It has great antioxidant properties. Obviously, defense mechanism is good here. Then calcium regulation, then antimicrobial properties, and environmental detoxification. And hazards, first we do know that formation of kidney stones, then obviously calcium absorption would be hindered. Then again, it will have some interference with medications. It will cause hyperoxaluria, wherein this calcium oxalates would be formed, and through urine there would be hyper amount of oxalates, so a clinical term here, hyperoxaluria. And then obviously during pregnancy the calcium oxalate crystals would be a great risk. Now let's talk of pressure amines. Now pressure basically leads to the meaning of it is basically contraction of the blood vessels, right? So these amines are causing contraction of the blood vessels. And if we talk of these vasoconstriction, the ones which come in our head are epinephrine, norepinephrine, dopamine, right? And these need some receptors. So this pressure amines will stimulate those receptors, in short, right? So if we talk of sources, there are some fermented products, meats, alcoholic beverages, etc. And these are two naturally occurring ones. One is tyramine and one is PEA, which is phenylethylamine. Tyramine is found in some fermented products like cheese, wine, okay, and it will stimulate the release of norepinephrine, which will lead to vasoconstriction. Here is the structure of tyramine, and the same way phenylethylamine. So if we talk of the basic mechanism of action of these pressure amines, obviously it will first stimulate the receptors of these hormones, right? The adrenergic receptors if we talk of. Then it will, so basically these receptors have two, right? Alpha and beta. Alpha is known to have a vasoconstriction effect and beta vasodilation. So if we are talking of vasoconstriction, we'll be talking of alpha adrenergic receptors, right? So these pressure amines will stimulate these alpha adrenergic receptors, as a result of which it will lead to vasoconstriction. So vasoconstriction, what will happen? due to which the blood pressure would be raised to a very great extent. And this is related with the conditions wherein hypotension or shock is there. And this, along with the increased cardiac output, basically the volume of blood being pumped out of the heart in from the single ventricle, that is our cardiac output, so that will be obviously more. So both of these things will lead to overcome hypotension or shocks. If we talk of benefits versus hazards, just now we talked of treatment during hypotension, then management of shock, then support during anaphylaxis, treatment of bradycardia, obviously slow rate of the heartbeat exactly, then improved organ perfusion. And if we talk of hazards, obviously, what if the blood vessels are constricted to a very great extent, even more than required? Then what will happen? The supply of blood, oxygen, both things would be hindered to a very great extent. Then arrhythmias, then increased cardiac workload, hypertensive crisis, extravasation, the leaking of these blood vessels would occur, or tachyphylaxis. Now, if we talk of reduction, how to reduce these anti-nutritional factors, so some methods are soaking, autoclave or cooking, fermentation, others are germination, right? Soaking, as we already know, what will it do? It will basically, these anti-nutrients which will form complexes, right, which are water soluble. So basically what will they do? Because we are soaking these in water, it will enhance the removal of these anti-nutrient nutritional factors from the foods through leaching. And cooking, obviously we are raising the temperature, so basically most of the anti-nutritional factors are heat labile, correct, because of which what would happen, this high temperature will effectively reduce the anti-nutrient levels. Again, fermentation is also one of the reduction factors of ANFs. So if we talk of the major differences which are there in terms of nutrient, trypsin inhibitors will reduce proteins, phytates will have these ions, then oxalates were prominent as calcium, and pressuramines, basically the catecholamines which are norepinephrine, epinephrine, dopamine, etc. And if we talk of hazards which are very prominent in each case, these also we talked of, right? Acute pancreatitis, then here mineral absorption is reduced, kidney stones, then hypertension, shock, ischemia, arrhythmias, right? So these were the differences. Thank you.